Hello everybody and welcome to a special episode all about joins. Now, when the video proper starts, I will be greeting you again. That's because when I was recording, I thought it would have been an uninterrupted stream. It turns out there was a bit of a problem with the encoding for the first 10 minutes or so. So when the video proper starts, you will see it choppy. It will be choppy for about 10 minutes. Don't worry, don't drop out of the video. The first part, luckily, is still fruitful, is still interesting, probably, even with the choppiness. And about 10 minutes in, I stopped the stream. I started recording. It turned out OBS had changed, an OBS update had changed some of my settings. So the rest of the 2 hours long video are actually perfectly fine. Now, the other thing which I do mention several times, probably scattered around during the stream, is I wouldn't want this particular episode, this particular special, to be misinterpreted as an argument to encourage people not to look into Maya. Software dexterity is important. Knowing how the software works and what you can get out of it out of the box and what the quirks are, all of that stuff is actually valuable. But there is one thing that I do not like, which is when it comes to joints and skinning and so on. Joints have a very odd, very mixed up identity. Joints are actually types, primitives, whatever you want to call them, which have a lot of peculiarities that are meant to address workflow for IK, as well as altering for skinning and painting and all of that. They have other attributes that are supposed to help with the visualization of things. They are treated very specially when it comes to a bunch of things that regard rigging and so on. And all kind of myths have emerged about what the joints actually do versus what the solvers do and so on, which I think are misplaced. And then people are often taught techniques in terms of like, oh, if your joints screw up, you should do this and then that, or you should always order your joints in this or that way. And there's a lot of superstition around them, and I don't like it. They're actually not straightforward because there's a ton of stuff. There's a lot of conflation. They do a lot of things that they shouldn't be doing. But they are pretty transparent, actually. It is perfectly possible to figure out exactly what every bit it is inside a joint is actually doing in every context that that joint might be used in. Now, the last thing that I want to say before I leave you to the video proper is what you see during the stream is, it's just a couple of joints going into a cylinder kind of scenario. The point isn't illustrating everything that Maya can do. There's a ton of stuff. There's a ton of scripts floating around. There's commercial plugins. There's a lot of tools that keep getting added to the Maya vanilla toolbox that could very well be working around or working through some of the problems I mentioned. It is not a comprehensive guide on how to use joints extensively inside Maya. It's an explanation of what they actually really are and what they contribute to. And then feel free to explore the software more, and at least you will be doing so after the video, hopefully, if you weren't clear before and you were taking them for granted as some mystified element of your working day. After the video, hopefully you will actually find them a little bit clearer and you will understand what they do. And with that, I am gonna leave you to the video and enjoy. Hello everybody, and welcome back to the stream after a long enough absence. DST finally kicking in, which means that I can stream at a time when my daughter is not having breakfast before childcare, and it is not a crazy time for Europe. And yeah, so we're back, and this is gonna be all about joints. Now, this is not really part of Season 1. It kind of toys. What this comes from is we've had a little bit of a Twitter debates about joint orients. And we're at the point with the actual Season 1, which will finish, I promise, where it is getting to the point where we just have to debug the rig just once, and then it's pretty much ready for binding, which does have some interesting things. And I thought, okay, actually, it would be useful to go over joints and skinning in its own right, and this is going to be a visually very boring session. Like, I don't need to show anything complex. It's just the theory and the attributes and the parameters behind these primitives. And then that debate came up on Twitter between me and a couple friends. And the internet is terrible. Like, if you just read the tweets, it might sound like we were arguing with each other. Actually, we know each other. But a lot of people picked up on it. A lot of people thought it was interesting. And one of the comments that I heard the most, which prompted this stream as a standalone thing, was people said that before reading the thread, or before, in other cases, before other episodes of the code, they found that they had never questioned some of the status quo solutions, some of the status quo ways of doing things in Maya. And we've been doing, a little bit of myth busting and legend fighting in Maya, things like, oh, expressions are slow, and it's like, whoa, why? Or, you should do this and you should do that, and again, why? And in the case of joins, some downright incorrect things, so I wouldn't even call them myths, which normally have some sort of foundation, some sort of root into reality that just got exaggerated or transmitted in a shamanistic fashion, as is often the case with rigging techniques. They're downright incorrect. People have assumptions about how joints and skinning work that I strongly disagree with. I think they're factually incorrect, and I thought, all right, we can definitely do a stream about it. So let's go into this. Again, this is gonna be a visually somewhat boring stream, but I think it's pretty useful to know some of these. And I think that it's probably necessary to start with a little bit of a distinction. So joints in Maya, I assume everybody who watches the stream is familiar with the notion, but joints in Maya are fundamentally a primitive. Okay, so the thing that we're interested in, if you want, in Maya, is that they are a type of sort. So when you create a joint, you have an entry in the scene, and that entry is of a specific type. So if you're tooling the rig, they're very easy to individuate. You can actually query the scene to get everything that is a joint by just giving a type to the ls command. If you want a string for it, you can use them for filters when you're actually using an iterator. So there is a very strong positive motivation in using joints when it comes to tooling your rig up. Now, the part that is important, though, is knowing what they actually do and what you want to use, what qualities they possess. Now, another thing that's probably pretty important, and I hope the text is big enough. I know that at 1440p, like, the text in the outliner is always super small, but we shouldn't be caring too much about it. The part that's probably important to understand here is where joints kind of come from historically, and the time that we're born, and the reason why I'm mentioning tooling, is somewhere around the mid-90s, right? When I started doing CG, and this makes me feel a little bit old, though I'm not that old, IK was something that I think only Softimage really had. It was introduced for, around the first Jurassic Park, so you're talking like very early 90s. And if you use Light with 3.5 on Amiga, or Light with 4 on PC or something like that, you did not have IK. And it actually took quite a long time for other applications to get IK. Now, the thing that is funny about IK, and it's easier now if you look at where modern applications got, the way, and as much as I rag on Maya can kind of still be considered a modern application by most standards with all the revisions they've done, or Houdini, or whatever survived the great application wars. A lot of stuff like Sega Animanium and Animation Master, they've kind of, or exercise, sadly, they've been discontinued, or they have, they're filling a super small niche. But you did not have in the past a view of the graph or things like this. So a lot of stuff had to be done very, very specifically. And IK was one of the first things that motivated isolated primitives. So you create something, and they are transforms, right? Joints are just plain transforms. But they have some peculiarities. Now, the first peculiarity about it is drawing. There's nothing else that I know of in Maya that does this, but if you look at a primitive, if you create a joint on its own, when you create one and that's it, this is your joint primitive. Okay, when Maya needs to draw something, if you were to create some other primitive, Normally what you actually have is a transform that holds all of the usual transformation properties. So you have all the pivots, you have the actual transform, and if you expand the node you will find all the things that we've been using a lot when doing straight up math to manipulate things, like all the matrices that Maya produces to place the item in the scene and to keep track of it and so on. Now the drawing part, when the viewport gets to identifying that the transform is within the actual view boundaries, rendering is a different thing. We're only looking at online, you know, OpenGL rendering in view. When it finds the transform and the bounding box of the item in the boundaries of the view, then it actually passes on responsibilities for drawing to the shape. Okay, and there's a whole bunch of things like sorting the triangles and all of that stuff that comes with it. Joints are super particular, and actually a long time ago we had asked Autodesk if we could have access to something like this, but it's apparently pretty deep-seated in the roots of Maya. Like the primitive for the joint itself draws as a circle, and that's it. And then you actually have the joint orient, and that is all it does, right? And on top of that, then you have the actual rotation and so on, which does not affect the primitive. And that is absolutely crazy, right? So this thing that draws is completely implicit to the joint. It pretty much ignores the rotational part, and I believe that it actually does. No, it ignores the scaling as well, and all that it actually relies on to draw something is literally the translate, to place it within the view boundaries, or within the word actually I should say, and the joint orient, and that's it. And the size of the joint is actually determined by the radius parameter of the joint itself. Now that in itself is pretty nuts, and that is one of the things that causes a lot of confusion when people talk about joint orients and sorry for that, joint orient and dealing with that. What is even more crazy, and if you look at some other applications, like XSI didn't have joints, XSI had bones, which feature the length parameter. If you parent joints, then Maya, in the actual drawing loop, or before the drawing loop when it's forming what is actually going to end up in the view, will draw this icon, this triangular icon, between the joints for you. So the name joint is actually correct. What Maya has is joints, not bones. They're supposed to be placed at the joints is something. But the way they're drawn is super wacky, okay? And this is one of the things that confuses people. Now, it is lagging for me as well. Oh, really? Oh, that is... how bad is it lagging? I cool close. Is the audio actually good? Because Twitch is... Sorry, I'm interrupting for a second because people in chat are saying that the stream is lagging. Fine here, audio's fine, so it's followable. Oh, the stream itself is lagging. So it's not like it's choppy or something like that. It's just, is it laggy as in it's buffering, or it's choppy and losing stuff? It's been working very fine for me. Okay, so it might be a bandwidth thing. Normally I turn my VPN off for streaming, and it's on now. Some people are saying it's fine. Lower FPS while audio is fine. Okay, thanks a lot for letting me know. I don't want to stop the stream because I've actually already talked for a while, so hopefully it'll be manageable. I'll keep an eye on chat, and some people are saying it's okay. The recording should be fine. I appreciate the people like coming online live for the stream. You're the heart of these. But all right, let me know if it lags to the point of not being usable. But okay, I'm not gonna repeat that comment. But the recording should be fine, I'm sure. If it's only lag like that. So going back to it, now the drawing part is super wacky, right? And this is one of the things that confuses people. Now, if you have been following the code for long enough, you probably saw that when I was using joints, which I was, to establish the deformation part of the rig, I was always actually, let me snap. I was actually always drawing them like this, and then I will control their parameters, right? So if you draw them down some axis, normally I think the x-axis by default is the only part which will zero orient. You can't really change what Maya considers the base orient, the base orientation. Then they will have no joint orient, okay? Which is one of the attributes that that I'm fiercely against. The same way that I don't think that pivots and transforms are a very good idea, not when you're rigging. Yeah. So what happens is that now, when you actually do anything to these joints in terms of transforms, you can see that the only thing reflecting the rotation is the actual bone part, the part that connects the joints. And this gets ridiculously confusing when you get to the last joint in a chain. So you do something like this and you're transforming it and absolutely bugger all happens, right? So this is the first part that makes people feel that they need joint orients. Now, before I start ranting about joint orientation, whatever you want to call it, there's one thing that's probably worth noting right away. I am not suggesting that people ignore their existence, that they ignore what the joint orient attribute is. But I would very strongly suggest that people learn to work without joint orients, and then you treat joint orientation as a bad practice and you learn to work around it. You learn to work with it when you encounter it in a pipeline, if you're work for hire or if your supervisor loves them for some reason and so on. Very much like bad programming, in the wild, it is inevitable that you will encounter it. So you should know what is going on. You can't completely ignore what is going on, right? So you should know what they're about and how they work and all of that. But what you should not do is treat them like some mystic artifact, where you have a bunch of rules to follow. And so they're telling me the video is lagging really bad. What I'm gonna do is, if you're watching this on YouTube, you probably won't really notice anything. I'll stop the recording and I will splice the video together later in editing. So that's why we're discussing them and explain what they are, what these parameters are. And you should learn what they do. Remember, working in a team, working in a facility is very different than working on your own. You might need to do things that are non-ideal or that you don't like. That's the nature of working in a team. But if we're talking about studying and understanding things and their first principles and what they actually do under the hood, that's got nothing to do with these superstitions about what they actually do under the hood. Now, with that said, so that's basically the wackiness of drawing, which already makes people think that, oh, I need joint orients, right? Because I need these to be aligned to the rest. And the super wacky thing is that then once you control the joint orient, there's nothing in Maya, there's no tooling for the joints that will allow you to compensate that joint orientation. And you can find a ton of scripts on the internet called like realign joint orientations and so on. And I don't know, maybe they added something in Maya 2017 or 2018. But scripts and stuff like that will basically do the equivalent of taking this angle here, pasting it in the joint orient here, and then zero out the rotation, right? So a lot of tools will basically do that for you so that your joint orients are nice and aligned to the way your skeleton works. Now, all you're doing when you're doing something like that, literally all that is going on is that the joint orient and the local transform are multiplied the same way that we've shown transforms actually work, okay? So if joint orient didn't exist, Maya would already be faster because it's a pretty big, like there's a lot of floats. When you look at how many bones you have in a skeleton, it's a lot of floats that are being tossed around and multiplied for no particularly good reason other than to address some really old misguided idea when it came to drawing the joints. Now, it doesn't mean that if you zero out the joint orient, your rig is going to be faster. I don't think that Maya does anything to keep track of what is zeroed out or not. I've never really seen any difference, so there's not really a performance difference. There's also the attribute rotate axis. Yeah, there's all kind of stuff, and there's the preferred angle is actually for the IK side of things, which is more useful. But there's all kind of stuff that is tied to the joints as a primitive that is related to tooling, but only for skinning. And rigging has been stuck with skinning for a very long time now, and there's hardly anything else other than skinning and shapes that people do. You know, Delta Mesh is probably the only big revolution, which is basically a pre-transform smoothing with an offset reapplied. So rigging is awfully behind when it comes to tech when you compare it to something like rendering. Now, that rant aside, that deserves its own episode. That's what's going on. Okay, so this is the drawing part of it. Now, there's another part when it comes to joints, which is tooling. So again, when joints came into existence, if you want, in the industry, whatever that means. What side have I drawn on? Okay. There wasn't much more than skinning, and tools were very specialized in general. So tools tended to do toolkits, entire toolkits tended to do more or less one thing, and that was your workflow. You picked up an application like Maya or Softimage 3D or XSI, and there was a prescribed workflow and things were simple enough. Then they made the application more modern, more powerful, you know, they let you have more and more control over the graph. Then with parallel evaluation, they actually simplified or complicated, depending on which side of the fence you're on, the graph itself, whole bunch of things. And this toolkit that you now have to deal with skinning and joints and so on is seriously constraining and outdated. Now, the first thing is IK. Okay, if you want IK to be created without issues, like, you basically need to feed it joints. Okay, so you will normally give it, I don't remember if you need to give it just the two ends or the whole chain. I think you need to give it the whole chain. And I've shown on Code of Rig, I've shown on the stream actually how to not use IK at all. You can just replace it with a triangular solver. So have I just created it in reverse? I suspect I did. I should actually create handle, so the start joint and the end joint for the effector. Okay, for some reason it is. See, this is at this point, like, IK needs to store rest angles and stuff like that, and already by default, like, you get all kind of stuff that you really will not want to deal with, like all these kind of artifacts. First transferring pushes the orient into the orient on the joints, no script needed. What it doesn't do is push it in the orient and keep them on a single plane. Yeah. No, no, and that's one of the terrible things. So you have preferred angles for the IK solution, and it's just ridiculous that all of this stuff. So that all of this stuff happens at all is, it just does my head in. Anyway, so that is the effect you get when you create the handle. So a lot of stuff is purely relying on the actual tooling requiring that you work a certain way, despite the fact that you can then get rid of all of it, happily get rid of all of it and not have the problem. Now, if you do the same thing, and again, I'm not fond of the IK solver in Maya to begin with. So if you actually create the IK handle right away and you let the drawing create the handle for you, then you need to go in and actually, which is super silly, and you actually need to zero out the joint orientation yourself. Okay, so did I? Okay, they create the handle for me. So if you do something like this, now you have a whole bunch of joint orients that you need to deal with and that you need to put back up there. Okay, so you are doomed to do this work. You have to hope that it works out for you in numerical terms. And that is another thing that people often script, right? And again, this is purely predicated on how the tooling works. There's nothing in these numbers that Maya needs or cares about that makes any difference. It is just the way the tooling itself works. So you push yourself through this pain, or you write yourself a script to do it, so you forget about it, and from there it becomes a superstition. This is the 180 that's probably messing it up, that is preventing the reach. Where is it? See, these are the things that make me absolutely despise. Huh. Okay, this actually didn't take as I did the work. You're also in for a word of pain when it comes to undo, in my experience. Yeah, and the solver will be slow. Yeah. There, is set to -90. Whoa, no, not quite. It's not set to -90 because it can't figure out the orient space from the root. The root, instead of going down the x, is basically, as it was drawn, it's going down that way. So that's why the -90, because if you use joints this way, which is the way the toolkit kind of happens to want you to work in without buffering them. If you buffer them, usually you don't get these issues. So when I was showing them in the stream, it just didn't happen because they were properly buffered. It's just that the way Maya works, by default, it decides that X is down that axis. And if you draw otherwise, it will need to orient that way for you. Okay? As a rotation, it is correct. That is what's happening in word space. Now, the part that's doing my heading is that these did not take. I don't know if I messed up the paste. Now, that 180 with the -28 should not be an issue, actually, but... So that's probably the part... No, that's correct. Okay. See, it's not taking there, which is the part that's doing my heading. So it doesn't want that. It does need some rotation. And if I zero these out, then it's good. Yeah. So that rotation, once the rotation in that third field is in, giving it the angle works out. So anyway, I guess point in case, it's the tooling that forces you into dealing with it. But per se, there is nothing in the actual IK solver, the handle, or anything that requires that you have joint orient. You still have to give it preferred angle. Preferred angle has got nothing to do with joint orient. You don't have to give it a preferred angle. And the preferred angle is a different thing, especially if you have multiple. Like if you have just 2 bones, you don't even need it. Okay? Not even for the solver to blend. If you have 2 bones, this is a law of cosine solve. Now, even if Maya runs an iterative process on the IK solver, it does not care about a preferred angle because it will always constrain appropriately. And now I did spend some time, I believe, on IK. I think there's a full episode explaining the differences between the types of solvers and all of that. When we wrote our own as a single, expression that you could probably fit into one line. The preferred angle is when you have situations that are very different, where you have something like this. So if you have something like this, there is no one solution, because the 3 bones could go this way, or they could go that way, or they could be zigzagging like this, or zigzagging like that, right? So for a solver to know how to deal with these multiple angles, then it might want the preferred angle to help the solution. Okay, but that's about it. It doesn't strictly need one. It will have a default stored for how you created it, and that will get you by most of the time. That is neither here nor there, too. Yes, if your joints are a straight line and locking, you just preferred angle will give it a bend direction. No. Yes, but you don't need it when you have just 2 joints, because if you have an up vector, that solution, that angle in between, is going to be just fine. In either case, like the joint orientation itself doesn't have an effect. And this is why I'm saying joints are super wacky, and it's important to know where they come from, because a lot of stuff that is on the primitive that you lug around all the time has absolutely nothing to do with a joint primitive in regards to skinning, in example, but it has to do with IK. Some other things might have something to do with skinning and nothing to do with IK, like the inverse scale, which compensates for scaling. So, and this is the other part where you go, okay, if you scale a joint without the bone, you won't even know what you're doing. And then there's a segment scale compensation. So if you look at what is going on, I'm scaling these, and instead of the classic hierarchical behavior that you will normally get when you transform something like this, sorry for that, what you get is that the length is changing. So if you look at the way XSI bones were, which is going to be pretty hard now because it's been AOL for a while, it had bones, it didn't have joints, and it had the length parameter that was actually feeding into the skinning. I'm not gonna say it's a better way to do it, it's just, but skinning is so ingrained in the way you deal with joints that it's pretty crazy, and you're paying for it all the time. Actually, I don't want this joint orient here, please. And this is the other thing that, you know, when you start moving your chains around, this is the part that confuses the hell out of people, because you go like, oh, but this is oriented that way, and it's now showing me the orientation of the previous part. So hopefully that part is all clear. These are all the quirks that you have to deal with. And by the way, let me see, I normally just disconnect these. I normally don't even use the Maya skinning. If you don't connect the inverse scale, which is the part that drives the segment scale compensate, so you, and Maya will, if you don't have these off, Maya will constantly recreate that as you repairing joints and so on. Then I believe that even in Maya, like, yeah, there you go, the scaling becomes normal behavior, okay? So that's the other part you need to know. And again, there's this silly quirk where I'm scaling these. Now, it is actually technically correct when you scale something that doesn't have a shape underneath, that this is not changing its size, because it's not transforming anything. The draw you see in here is drawing this parameter, which is upstream of the actual scale parameter, right? It's an actual parameter of the primitive. And this is receiving the effect of that, so it's getting scaled up. Again, it's more quirks, it's not technically incorrect, but you gotta know basically what you're getting yourself into when you use skinning and what you're doing, and your life might end up being a lot easier. So hopefully that part makes sense. Do we have any questions about the first rant about IK handles and the way joints draw as primitives? There you go. I forgot what a pain in the back it can be. See, then people ask me why I don't like joints. If you give it an up vector, it actually shoots off. We should probably try that, in fact. What did I want? So I don't even remember the standard constraint, because I normally just write my own 2 lines of code that are required for a pole constraint. No, it's in the skin. See, is it IK handle and pole, whatever it is. So somebody that deals with this pain all the time, remind me where the skeleton pole constraint is, please. Enable whatever. Oh, screw it. Doesn't matter. Preferred angle, man. Now that's the thing. I don't want preferred angle. It's in constraint. Yeah. So I was just selecting wrong, because I remembered that being no valid. So I want the, okay, other order. Have I? Yeah, I just messed up the. Now the other thing you have to do when you look at that, and the other thing that Maya does that is super peculiar, is you have the solver, which is actually gonna be in the scene root, and is shared because of performance reasons of what allegedly is shared between all of the various chains. So if you export the actual solvers together, and Maya will create all of these nodes for you when you create your first IK handle. If you export these with your model, because you care about the settings or whatever, and multiple models come in into a scene, it can make a mess of things, which is another reason why I don't particularly like this. This is a solution that is fully local, should be done localized, but for some reason, you know, no dice, it work out like that. So IK solver, come on, there you go. So there you go. You don't need the preferred angle. Sorry, it takes me a long time because I normally don't do these things, but the numbers and the math behind it are pretty trivial. The preferred angle will help you if you don't have something that gives you the plane and angles of resolution and all of that. You don't want it, but Maya does. What I don't want, the preferred angle, I don't need it. I don't need it for a 2-bone chain. You don't need it. That's the thing. It's a myth that Maya wants certain things. The toolkit, the workflow, might be easier because Maya expects you to do things in a certain order, but then it becomes superstition that you need it. You don't. It is not part of the necessities of figuring out the IK. It absolutely is not needed. To know how to draw this triangle, if you have 2 points, 2 lengths, and an up vector, that's it. That's all that the mathematical solution requires, and that's all that Maya actually requires if you give it all the elements. If you don't use an up vector, then if you want a pure plane solution, then yes, you have to give it the angle. Well, actually, no, not really for 2-bone chains because it can still be solved, but that is a Maya quirk. But if you add more than 2 bones, then yes, you need to give it angles because it's exactly how solving a triangle works. Or in fact, how solving any polygon, or in this case, you know, really messy intersected multi-polys actually work out. So I think that more or less covers the drawing part and how those attributes interact and so on. Anything in chat about what we've gone over in so far? I'll do a quick recap in the meantime. So joint itself, pile up the questions before I move on to the skinning part, if there are any. So what it boils down to is the joint is pretty much a transform almost like any other, except that they decided not to have a pivot, but instead you have all of G's joint-like parameters, which is another reason for me to not like either pivots or joint orient or any of these things. It introduces differences between things. Your tooling and your handling of anything becomes considerably more complex, especially if you start mixing joints and other types of transforms, because you have this massive discrepancy in how things are calculated. Okay. The drawing part of the joint itself is entirely determined by this weird thing that comes with it. So where every joint basically always shows you its local transform moved by, so the word translate, then it will show you the rotation of the parent. So it will show you the rotation, like the orientation of it is going to be matching the transformation in word space, so by the parent. It will ignore the local scale, and the actual joint orient is the only thing that will alter the rotation of that in relation to the parent. So it's these pre-multiply, remember this is Maya, multiplied by that basically. So that's all there is to it. Preferred angle is purely an IK thing. If you have an up vector, which you probably should almost always have, then you don't really need it. If you have non-planar chains, then that's a different matter. It gets a bit trickier, and that is when you actually really care about preferred angles, because if this is your solution plane going here, and for some reason your IK chain needs to go down that way, and you don't want to do it with a planar chain that then has offsets riding on it, which will probably be a smarter idea in general terms, but whatever, you might have your reasons, then you definitely need the preferred angle. Otherwise, Maya will take whatever you have and squelch it down on the plane that you need. That is pretty much it. Now, remember we said the scaling is not represented. So super quick recap. There's no way to make it show that I know of. Somebody that is more bound to the tools than me might know differently, but I've never seen the scale working on joints other than representing the parent. So it's the same logic and the same behavior that you have in rotation. By default, when you create something, Maya, again, this is a skinning type things. If you have segment scale compensate and you rearrange joints, like you reparent or whatever, it will connect this inverse scale attribute for you. So a parent will transmit the inverse scale. You will tell the joint what its inverse scale is. And that is so that Maya can do skinning specific things. So instead of this FK-like behavior, Maya can do something like just scaling this bone and leaving the rest untouched. So there's a lot of responsibilities being conflated to the joints. Also reason why I don't particularly like these. I'd rather be in control of that myself in the rig. And what else is there? And I think that's about it. Now, the rotate order is one of the funkiest things. As in, people think that the rotate order is somewhat magical on joints, I found. There's nothing to it. If you understand rotate order in normal transforms, if you deal with it in normal transforms, the rotate order is absolutely relevant, and we'll get to that more when we get to the skinning. If the joints are actually affecting a bound mesh, so if they're driving your skinning, it doesn't even matter if you have 180-degree flips or anything, because so long as subframe, the controls that drive the joints are consistent, it doesn't matter that these jump, and we'll get to it when we get to the skinning, because the points get transformed by a differential which is extracted from the matrices. So the rotate order doesn't matter at all, so long as you drive the joints from something that is consistently well behaved. So, do you also write your own IK solver for joint chains with more than 2 joints? Yes, they're pretty trivial to write. There's trapezoidal solvers that work really well. I'll take, before we get into the skinning side of things, I'll take a super brief tangent for these, I guess. So, because it does kind of touch on the IK solver thing. So as I said before, if you look at the IK episodes for Cult of Rig, the moment you have an up vector, let me toggle the display, and a root, and the, let's call it an F vector if you want the IK term, so the end of a chain. Now, and you have 2 lengths, so you know that these, whatever it is, needs to be this long, and these, whatever it is, needs to be this long. Now, the up vector and these 2 points give you a plane, which means you're solving a planar triangle. Triangles can only be planar anyway, right? Then you can orient these that way, and you can orient these that way, and there is only one point where they touch, because you're working in a semi-plane thanks to the up vector. Okay, so that gives you the IK solution. Oh, this is gonna be super true. Oh, wow, go me. Probably should have chosen a brighter color, but hopefully you guys can see it. So that is how it works. You establish a plane, the up vector gives you a plane and a semi-plane, because it chooses which side, because there's another possible solution, obviously, that is that. And then all you care about is if you have the 2 lengths, you get there. And this is how it works in trigonometry, right? Any triangle can be solved for any 3 elements, provided you have at least 1 length. Because angles could give you something that is any. If you only have angles, you could get any scale. So in IK, if you have 2 lengths here, and you have the distance between the root and the effector, then that's your 3 sides. You solve the triangle, and for the which of the 2 triangles form, the up vector gives you that number of other things. Now, if you did not have the up vector, that is where this angle comes into play. And whether you get these or that, and I don't know if this is true in Maya, but there's a winding to this angle. And again, we touched on that, where normally, given a certain orientation of the axis, the winding will be counterclockwise, and I've just drawn clockwise. So in theory, at that point, the only thing that matters is not the preferred angle itself, which is just a bias kind of thing. It's literally the sign of it. Because if it's given the axis and the winding order, if it's signed positively, you get this. If it's signed negatively, then you basically want the equivalent of that in counterclockwise, so it's the negative sign like that, right? So that is the only time where the preferred angle makes a difference. And again, this is pretty basic trigonometry. So the other thing, which is the actual question, is if you have something like a quadruped leg, something like this, that is going to be 4 joints if you get to the ankle, which you normally want to, and 3 bones. Now, that is what I would call a Z chain. So this is a V chain, given the shape. This is a Z chain. It's very rare that you want to go from a shape like that to a shape like that. These are 2 different solvers. If you want them to be very, very fast, or they can be the same solver. Now you can start to see how if I have these 3 lengths, and these are both to reach the same point, so to reach from here to here, like both of these are perfectly valid solutions, right? So the preferred angle, and even then, you know, you could have something like this instead maybe. All valid solutions for the same lengths and everything. So this is where you have to give Maya more parameters, or any IK solver, in fact, more parameters if you want a generic solver. Maya uses an iterative solver, right? So what happens is that, and again, I was explaining this in the IK episode, so I don't want to go over it. Basically, Maya will keep orienting things, or any iterative IK solver will keep orienting things based on some parameters until it reaches a stable solution. So you know, it might orient these like that, and that like that, and that like that, and see, okay, how far have I got from this point here? And then slightly change that way, and change that way, and go, okay, how far have I got from there? Further, then, you know, it was preferable to take the path I took before for the first angle, whatever. Until it finally converges on something where changes in very small changes in parameter produce differences in the reach to here that are, you know, within precision boundaries or 0 or whatever. And that's why you have a rotate, like that's why you have an iterations parameter, which I think is in the general solver there. Max iterations, which is a crazy number. This might be max signed int or something like that. So it's, you know, all of the positive side of a 32-bit int. It will usually not be that expensive. Now, if you give it preferred angles, you know, if you want this kind of configuration, this relationship between the bones, to be your preferred one, instead of, in example, having, you know, something like this, where there's a much more pronounced kind of sharpness to the first joint, that's where preferred angles come in. Preferred angles basically give a bias to these parameters. Actually, let's keep the winding consistent. Preferred angles, so this is equivalent to the negative, okay? Preferred angles basically give the solver a bias to do this kind of work. That's what they are for. Now, the fact that the preferred angles are with the joints, so if you know, it just kind of does my head in a little bit, because the solver is separate, the IK handle is separate, but the attributes that are purely IK related are actually on the joints. It's like not super fond of that. But, you know, it's the way a lot of IK solvers actually work. I haven't seen the one in Udine in a very long time. I don't remember dissecting it. The one in XSI kind of also had the same conflation of responsibilities. Whatever. Now, this is actually a pretty straightforward solution where you have one side, right? And you have these lengths here. So it's actually a very, very well constrained solution. A C chain is super easy to solve. It can, you know, solve for something like that, but it's kind of, if you take this quadrilateral, you take this trapezoid, it's like there's very little give. It's kind of like, how much can you move this thing here? So you can do a handful of interesting things, and there's many solvers you can implement. If you want performance, you need to implement them separately. You could link it to the app vector somehow, so that when the app vector is moved around, this part gets wiggled around. There are some things where that is super convenient, especially for robotics. It can get pretty funky. Or you can choose to give to store the rest angle when you first create the your compound, or have them actually on the solver or something like that. Because if you create solver for a fixed number of joints, they don't need to be iterative. They can be a lot faster. If you have your rest angles in there, you can pretty much very easily configure the quadrilateral. Something like this, normally, because animators will want some control, ideally both, where they can choose whether this is driven by, let's say it's a leg, this is driven by the ankle or by the root. It is not uncommon for something like this to be one solver that is basically, this is a control. Let me split the things. So this part is a control, and then this is an actual IK solution when your bias is fully at the hip, versus when your bias is at the ankle, this is the control, and this is your second IK chain, and then you blend the two. Okay, so you can solve for the rotations of the hip and the rotation of the ankle, and then you blend these two solutions, and it works really well, and it allows people to choose how to control these free bone IKs from the foot or from the hip, or any blend of the two. There's a number of other solvers that you can implement. Get creative. It's pretty simple geometry when you look at it, and it's actually really interesting to solve. Personally, I feel like this is what a creative rigor actually looks at. It is, knowing Maya software dexterity is important, but do not fall for the superstitions of you have to do things this way. There's nothing that Maya does. Maya might make some mistakes, or in fact, this is somewhat opinionated. Maya does some things that I feel are inappropriately placed and unclear, both in terms of performance and usability when it comes to where the attributes live and some of the default choices. It is something that is very inconvenient when it puts the solvers in the root, and it's the one solver parameter set for all of the solutions in the scene. Back then it made sense for performance. It doesn't so much these days. You shouldn't be enslaved to any of those. Know why they happen. Other than those choices, there's nothing special to what Maya does. It's all pretty bog standard stuff. And get creative, actually. You can do this stuff and it will be faster and more localized and easier to tool and export and all of that than Maya's solvers. You can even let the two-bone chain to Maya if you wish. Anyway, so that sub-rant has gone for a while. So let me stop that one there, because I want to get to skinning. This is looking like it's gonna be a very long stream, but I gotta get this off my chest. So chat, you all caught up with me? Is this making sense? I hope people are finding it interesting. At this point I'm kind of on a roll, so it's not like I'm gonna course correct massively. Now there's a last thing, actually, a last responsibility, which is insane. Sitting with the chains, which is blending IK and FK. That super does my hand in. Sorry, that is with the handle. And that is the final thing that makes joints special, I guess. Joints are the only thing, and sorry, not the only thing, they're not at all, but joints were made special in Softimage 3D, in Maya and so on, because they're the one thing, and this is super antiquated, but they're the one thing where, believe it or not, in the 90s, get off my lawn, in the 90s we used to lay out joints. Well, I didn't, but a lot of people laid out joints and gave them to animators to control. So the skinning, and it's, for performance reasons with the computers you had back then, it might have made sense, even, maybe, not sure, but maybe. So very often you would maybe hide a bunch of things, maybe lock a bunch of things, but animators will get something like the IK handle, every constraint matter, you know, and so maybe even the IK handle row and the couple joints. And XSI made the same mistake, for the record. And then you could control the bones in FK, right? Or the handle in IK. And then what happens is that if you're in IK mode, you key the handle. Now, this is actually pretty neat. When you think about it, like, this is a circularity. We've touched on this before, you know, with sync constraints that are basically circular for the sake of manipulation and so on. What Maya is doing here, as you know, if you look at it from an ignorant perspective, as in you're not a rigger, you don't care about the mechanics of these, you're an animator. This is very desirable behavior. You being able to select something and manipulate it the way you want it, and the other item becomes codependent. That's great. Now, not gonna call it a problem, but the part where it falls apart is where, you know, you key the rotation in something. And this was even finickier, I believe, in soft, but anyway, it doesn't matter. So you key it, then, you know, you scrub your timeline and you go like, okay, what is going on there? So what happened is that by moving it the second time, you moved in the interaction part, you moved the IK handle. God forbid, if you forgot to key this, it's now off, right? Now, if you key the IK handle as well, and this is where you start getting these double up joints. This is, I believe, Maya showing you both or whatever. Maybe I've duplicated something, I don't know, but I don't really care. What happens is that now you don't know if you want to solve for the IK or for the FK. I think it's just Maya showing you both. Yeah, there you go, FK. So this tells you how I don't really use it much. But this is an entirely manipulation artifact. Then if you look at the handle is the one where you basically get to choose whether you're in FK or in IK, right? And this is where we basically had let the FK drive us. So let's go where they're further apart. So now you have something that is on an IK handle that is probably somewhere in your hierarchy of the controls, right? And hopefully you have these under a buffer and these attribute you're reflecting there. But anyway, you get the idea. So this is all done conflating manipulation, display, solver behavior, and even some skinning behavior, and the scale compensation and so on. And people say that, you know, the way I suggest doing things, which is a little bit more raw and primal, might be hard to learn or complicated. I mean, I've been using Maya for a very long time, and you know, my dexterity is pretty low because I don't care about these details, but I think I know the guts of it fairly well, and I know what all these things do on a numerical level and so on. You can't honestly tell me that this is simple. I just don't believe it when people tell me this is simple. Seriously? Anyway, so that's the last bit of the historical perspective of why things are where they are, right? These days, it might not be such a super great idea to have so many things conflated on what was essentially two bones, okay? I'm selecting a handle. All I wanted was two bones, and I got these. Seriously. Anyway. Nobody used that. It is so weird. Actually, you'd be surprised. A lot of people use it. So the manipulation part, these days, almost everybody, let's say modern rigging, post-90s rigging. I hesitate to call it modern, but let's say it is. Almost nobody, unless you're in a very low budget, quick and dirty kind of scenario, will show this stuff to animators. Normally, you will always dress it up. Right? You will always go, okay, the rotation of these, and this is what we're doing in the rig for the code. The rotation of these will be controlled by something. And if you want Maya to do your IK solution, you can drive the handle with your own control. Drive the FK with your own FK controls, and your blend is actually gonna pipe into the handle's blend. And this is what is probably the most common thing. If you don't, and I think very few people actually put together their own IK. I've shown how simple it is, but once if you want to add a few parameters and so on, I think it's pretty rare, despite the fact that it's actually very easy to do. And that is perfectly reasonable. But, you know, you stash it away. So, now we're on to the skinning part. And this is what I will call straight up superstition, okay? So the joint orient thing, at this point, I still have no use for it, okay? Preferred angle, maybe, okay? Maybe you have a free joint chain. I'm not gonna be, you know, I'm not against that. There are cases where you don't want to write your own C and Z chain solvers. Not everybody can. You might have multiples, you want to use Maya's facilities, the blending becomes a little bit trickier and so on. Perfectly valid rationale. Don't really need them, honestly. Maybe one preferred angle. If you have something like this, you might need this preferred angle and this preferred angle, and they will give you the weight of how you want these things to space apart. Play with it. Get yourself a Z chain, get yourself the IK handle, move it away from the default, okay? Maya will use whatever you drew it in, zero out all of, given enough vectors, zero out all of the joint orients and so on. Maya will probably use the way you drew it as some internal rest angle, because otherwise it will not be able to solve it. So there needs to be some parameter about how they're spaced, angularly spaced, for them to reach the linear zero. And then play with it. Play with preferred angles and see how the relationship between these two angles is the most important thing that basically works for you. Let me see, using your screen to change that bias, right? Your points remain the same, but you will. Oh, this is really hard to do with the fingers, but it will change that bias. Any resources to learn about how these solvers? So IK solvers, like if you look around, you'll find some good stuff, but almost all of them tend to be iterative solvers, and some really good ones as well. You got, you know, somebody at Unity did the Jacobian solvers and wrote a good blog post about it. There's a bunch of secret papers. There's one by why can't I recollect the name right now? Guy that was a Fabric, also did CAT for 3ds Max. Phil actually had a paper at GDC on non-iterative solvers, but they're general solvers. This stuff, like, that's trigonometry. That's you being creative with the controls, knowing what you want to offer as a control, and finding a couple of triangles from it. You know, you go like, oh, okay, you know, the animator wants these controls and wants Phil Taylor. Yeah, Phil. If you're not on a first name basis, Phil Taylor, PHIL TAYLOR, wrote a non-iterative solvers paper for GDC. It's pretty old now, but I think it still stands. I've always implemented my own. I've looked at some papers here and there, but I've always ended up doing my own, either fully deterministic solutions like these, or I've wrote a kind of hybrid solver that was pretty cheap and fast. But it's not about that. It's about figuring out what controls the animators want, what are intuitive parameters, and go like, okay, given those parameters, given the animator wants to control, you know, this item or this item and a bias between the two, how can I reduce that to just triangles? You know, and this is the example I gave. And if you look at these, this gives you one side here. So it gives you, this triangle is fully constrained, whereas this triangle here is, you know, this side at least is, you're gonna have this angle here because they've controlled it. You're probably, you know, gonna be able to have this length here, or you want to find that length, and that length gives you that, whatever. Break it down. When you want a deterministic solver, it's not really an IK solver as much as you figuring out the geometry of the subparts of the component. This has gone down many tangents. I think I covered all I wanted to cover in the first 20 minutes in the last hour or so. So I thought I got better streaming everything, and yeah, but I've regressed anyway. I would really like to know what to you use as an alternative to joints and what is a better solution. So I'm not suggesting an alternative to joints, and we'll get into why you need them in Maya for the skinning. As for what I'm saying is I don't like the Maya IK, which requires you use joints. And I've shown how to write a simple one-line expression for a VChain solver, and it's not that much harder. And Charles Wardrow has, if you want another solver, a soft IK kind of VChain solver. Charles Wardrow has a really good one out there. But other than that, what I'm saying is not don't use joints. We'll get to skinning now, and we'll see how they kind of are a must for the toolkit to work, and then you can get rid of them, and we'll get to that as well. I'm just saying, don't complicate things. Same as transforms. I don't use pivots. They're just an unnecessary thing that might or might not be there, because you might or might not be using it as you go down a hierarchy. Then every time, if you want to tool the rig or if you want to debug the rigs, which has nothing to do with having to write code or whatever, you're constantly in this state where you don't know, as you visit an item, is this exceptional or not? Does this have this additional attribute which is not found elsewhere? And it's the same for joint orients, and the pivot in the transform is not going to be found there. So if you were to write code, or if you just look at logic, you get to the point where you go, it's a transform, I have to branch my thinking or my code and go, I'll deal with pivots. It's a joint, I have to branch my thinking or my code and go like, I'll deal with the joint orient. Remember, preferred angle matters none at all for the chain of transform. I have to look at the joint orient, and it happens to be an Euler transform, which is probably actually going to be added to these straight up. You don't see the rotation order of it, which is another thing that confuses the hell out of people, how the rotation orders here interact with joint orients. I don't know. They seem completely superfluous to me. In fact, they seem completely counterproductive. But let's get on with it. Man, this has got pretty horrifying. So let's do a new scene super quick. Does all of these make sense at this point? For some definition of sense. Okay. Oh, hey, Hamidou. So in the Twitch chat, there is a link to the paper. But if you look for a Phil Taylor non-iterative IK solver on Google, you should find it. Now, skinning. So, rigging kind of for deformation at one point picked up skinning. Great idea. Skinning was almost immediately made explicit, and we'll get to that. Shapes, if you have the memory, talking 90s. And rigging in 2018, and I think the first version of Maya I used was 1997, maybe the beta, or 1998 the final of one was out. 20 years later, people are still skinning and using shapes, and that is it. That is a bit of a sad state of affairs, and and they tried to put muscle systems in, and one of the major mistakes with that was that they were put in as a workflow. Okay, as in they didn't put in, they never put in a muscle system. They put in a muscle toolkit. And you used it a certain way, and you dealt with these quirks, regardless of the quality of the solvers and so on, which might also have been an issue, right? But, or you didn't. And back then, even more so than now, the graph was a mess. So, skinning and already like stuff like this in Rescale and so on, I detest that. And all these messages being passed around. Like, I don't like what this looks like. I don't like what it suggests. If we look at the graph, at the puppet part of the rig as a program which is expressed in this graph, there are many reasons not to love the way this is done, but it gets worse with skinning. It gets criminally bad, I would say. Dramatic much. So the first thing, maybe the first classic demo material, 2-bone chain and cylinder. riveting. Okay. Now, wait. Can I select them in this order, or is it gonna give me crap? Let's see. So this is one of the things. Sorry, I went silent for a second. I was kind of collecting my thoughts. Now I was saying, the muscle systems came out as a toolkit, and skinning, came out in the days of old, and we're still stuck with it. Now a huge issue I have is that I don't know if the intention was to make rigging something that artists could do, which is a noble endeavor, and I think it should be done to some extent that way. And remember, Maya is used by, I don't know, 500,000 people, and there's, if you watch the Code of Rig, chances are that, you're in the 99th percentile of rigging already. A lot of people do rigging that do not care for the way we talk about things and shouldn't. But anyway, I don't know if that was the endeavor, but Maya, especially back then, has always had a reputation of being really hard to learn, so they didn't do a really good job of it. The muscle systems were one thing. Skinning, from dawn of time, was always developed as a toolkit instead of a set of primitives and operations and procedures, and the toolkit isn't even particularly good, and it gets its own menu entry, right? There's no generality to these. Like, these are all things that under the hood are actually pretty generic, and you can decompose and replace them very easily and do better than, in performance and toolkit and all of that Maya does. The painting part is super painful, but to redo, that's really tricky. But other than that, it's pretty easy to replace it. This is all super specific, so let's stop rambling and let's bind, okay? Now, one more viewport thing about joints, and these days it's a little bit better, but one important thing for joints is that you could x-ray joints, and only joints back then, I believe. So if you x-ray everything, this was, I feel, done better in Softimage. If you x-ray everything, anything that is a triangle is shaded, somewhat transparently, and this is, it makes painting deformations and seeing the results of what you're doing really hard unnecessarily. And in XSI, you could x-ray everything that was not a geometry, and that was so much more useful. Because what happens is that active components is just a geometry point. So I see it still the same way in Maya. What happens is that you would, in theory, actually also want to see the handle. So anything that is not geometry, you will want to see, but you don't see it, right? You only see the joint. So this is only useful when painting weights. But this is the part where I'm saying that the joint as a type and as a primitive is conflated with the toolkit. You working as an author, so let's accept that rigging has two phases: authorship, which is you rigging, creating, creating the rig to hand over, and consumption, which is what the animators do. They're two very different states, possibly even two very different rigs. You as an author, you actually care about joints a lot more because you want your tools to behave a certain way. When you paint, you want to be able to quickly select something on screen, not select the geometry. Oops, X-ray doesn't, there's no option for that really. You have to go into another bunch of options anyway. And you want a certain behavior. And you can actually go select the IK handle without the geometry getting in the way, but you don't really see it, okay? So that's a conflation I'm talking about. For this reason alone, as an author, you need joints, and that's the end of the story. You will have a horrible time doing weight painting if you don't use joints. It's that simple. Now, this is the first myth that I would like to work on. I have literally been told, and I've heard it from more than one person, that if you don't use joint orients, how has it been phrased? Your transforms are less stable. That is downright wrong, okay? There is no basis in fact whatsoever. So let's look for a second at how skinning works. In fact, I will say the joint orient, if anything, if there was some optimization underneath, might lose you precision, okay? And we're talking precision, okay? People often say, oh, this is not stable. No, numerical stability has got nothing to do with precision. Precision, lack of precision or loss of precision might cause numerical instability, but we're talking about two different things, okay? So if you look at skinning, which, you know, it's a skin cluster F, you have a whole bunch of things coming into here. Now, the way skinning works is super simple. Let's see if I can do this. You have some bones, okay, and people treat parts of skinning with this superstitious reverence that it really doesn't deserve, okay? So maybe you have free transforms you care about, you know, and I normally will suggest something like that, where you have, for something that simple, I would suggest having at least a root. We'll go into kinesiology at some other point, but for the classic way where people skin the arm from the humerus down, a root, something just before the elbow, oriented the same way as that root. An average transform, this is what makes it easier for you to skin something that bends in a nice way. Something aligned to the wrist, so your ulnar radius, just off that, and you know, and your wrist, whatever it is. And with wrist, I mean the end of this. It should not come from the hand. This is the back of the hand or the palm or whatever you want to call it. It's a very different transform. Oftentimes people conflate the two. Don't. Terrible idea. Always decouple. And if you have a way to do it, you know, get yourself some slightly offset double joints so that you can do this kind of thing. Because that offset, especially if you can control it, will actually save you a lot of time in some cases. Because with tiny tweaks, if you're on a budget, and I don't know, I think in games some people have figured the trick out, but if you're on a budget, on a CPU budget or on a GPU budget, it can make a world of difference to space things apart as things rotate, okay? Now, with that out of the way, we'll leave dual quaternion alone, but all dual quaternion does is it takes different parameters to generate the transforms. If you have a point, so let's use red for the geometry. Now, you have a rest pose and the bind pose, okay? And you have a pose for the geometry, whatever it is, we don't care. I'm not going to discuss those, we'll go into it for skinning. But let's say that your relative shapes are those of a cylinder. And then you need some transform for the joint. All that skinning does is for each of these points, and well, you actually will have more than one transform. So I should have, let me do something like, let's pretend that this is the elbow actually. For each of these points, you're gonna have a relationship with all the influences in your bindings. We're gonna take the very naive case. It's another method to make it a sparse matrix so that it's cheaper. So for each point, you have a relationship with those items. Now, those items have two properties, okay? They have a rest property, which let's say is this, and that's a rest transform. And binding is a different thing, we'll get into that. And then they have the recurrent transform, which might be the one we're at. All that happens when you're doing skinning is that, I'm running out of colors, is that there is a difference imposed between these two items in word space, okay? Maya skinning, and this is deplorable, works in word space entirely. This in word space has probably been transformed, like, let's include the translation maybe or not, has been moved that way and rotated by this much, okay? This has been moved that way. This is really hard, okay? You get the idea? Despite, oh man, it's annoying me, okay. Has been moved that way and maybe not rotated in word space. This has been moved that way and maybe it's being rotated very slightly. Each of these points is multiplied. So if this point is bound to all three of those, is multiplied the same way we've shown. What did I say was deplorable? Because I've actually insulted quite a few parts. Which one are we talking about? Oh, the word space. Yeah, I'll explain it. Precision issues. Each of these points is transformed by all of these. So imagine these kind of becoming free virtual points. I've drawn these in the reverse, like this was showing the binding. But the reality of it is that this point of geometry here has been transformed by all these three. So originally you had this distance from wherever it was, and it's been transformed to here, here, and here. Okay, and this is where your geometry crumples. Basically, this is the classic things where you have the loops going that way. Anyway, yeah. So I'm drawing things a little bit weird, but hopefully you get the idea. Then each of these three transformations for that point that has been moved around from where it was. I have made a bit of a mess of these, but let me redo that. Sorry, because I need this part to be clear. So the point was originally here, and once transformed, this joint has probably moved it here. This joint would have moved it maybe here. Okay, oh, and that's the part that's confusing. Okay, so this is the first joint, this is the second joint, and this last joint that was here maybe moved the point here. Okay, now these three virtual points, these three transference for the three joints of this point, then have a weight, which is the stuff that you paint, which is a single float per point per influence. And you can imagine that actually gets pretty dense, right? The moment you have more than three joints, you're basically denser than the actual mesh point cloud. And that's why you need sparse matrices and all of that. Then that offset is multiplied by your weight. So sum average of these, weighted average by the weights that you painted, comes in, and this, so when you do the painting, you reduce this to 0.6, it moves here a bit, and you go, oh, I don't want as much from these, so you paint very little of it, so this has become 0.2, and hopefully you keep the normalize, which makes everybody's life easier, and you're left with a 0.3, which moves that there, and then those are average, and your final point maybe ends up there. That's how binding works. Okay, so that is how it works. That's the end of the story. Dual Quaternion does a slightly different thing where it runs the transform twice for the things that it finds, and it gives you sort of a curvy linear interpolation instead of that linear averaging, which is also volume lossy usually. So all Maya needs for any of these really is the matrix before and after the transform. Okay, so if you look at skinning, and sorry, I'm belaboring this to death because this is something that I've heard as a legendary superstition thingy. Your joint goes into the skin cluster with its word matrix. That's the end of it. Okay? So if your normal transforms have their chain transform, which is the same for the joints, and the pivots factored in those multiplications, your joint might maybe have the orient added to the rotate, but at the end of the day, whether you use the orient or not, Maya takes the local to produce the word matrix within the context of the parent, passes that to the skin cluster. That is the end of the story. Okay, so meat busted or whatever you want to call it, there is nothing in joints, joint orients, or anything that has anything to do with precision, where joints will be more stable than something else, or where orienting a joint will be more stable than not orienting it. So with that out of the way, the bind pose, which is a separate node, and you know some people say, oh, I wish it was on the joints. Now XSI actually had this bind to calculate the difference was on the bone. Maya chooses to have a separate node. I'm on the fence on what I think is better. The bind pose is a pain in the back to manage, and the way it's implemented with all the messages is very, very painful. Okay, but the fact that the bind pose is separate from the joints is actually quite good. especially when you're rigging multiple things with the same deformers. There's a few tricks that can come into play. You can even do things where you slightly offset. You have more than one bind pose on the same joint, more than one skin cluster, so you get 3 slightly offset. This is a very old trick, but it can still be used in some cases. You get 3 slightly offset meshes produced from it, or point clouds, and then you average those. You can do a bunch of interesting things, basically. So technically, having the bind pose separate is superior because it allows you to do some interesting thing. It is very, very painful to manage, because now, whenever you want to do any tooling for how the skin cluster works, you're managing your influences, you're managing the default state of that influence before it's transformed, stored in another node, okay? And that is the one that goes in. And you're managing the skin cluster itself, which collects the transforms. But even more, if you notice, the bind pose here is connected to something else in its same word space. And this is the part that can make for a lot of trouble, because lo and behold, at some point they did add the bind pose to the joint, which is when you do set bind pose with the joint selected, it sets these, which is then passed to the bind pose, which does not directly affect the skin cluster. There's some message in here, and God knows what's going on with these nodes, but at some point, Maya basically has to, before doing the skinning, it has to do a pre-flight where it finds the bind pose, it finds all the word matrices, stores them, because the bind is supposed to be unchanging for efficiency, but the thing is, you can actually change it. Yeah, anyway, so if you strip off that veneer of tooling and enabling things like, you know, skinning having its own menu because you have all kind of stuff in here, then, and you have things like move skin joints. Moving a skin joint by floating it like that is literally changing its bind pose, okay? So, I hope this makes sense. This is the way the relationship between the bind pose and the joints work, which is there's none at all. Okay, it's entirely artificial. It's entirely for the tool set and for the procedures to have an effect on. Now, what that means is that you do not need joints to actually deform something, right? So if I create, and I wish I had prepared scenes for this because this is going to be pretty boring, but bear with me. This is the word space that we're talking about, right? This is to, let's say, reinforce what I was saying before. I should use shortcuts for this, but whatever. I don't even need these things to be in a hierarchy if I want to emulate their behavior. So let's, is there a, they added a match transform actually, I'm told. So does anybody know where it is? Is it in edit match transform? They added it quite a while ago. I always forget where it is, because everybody wrote this script like ages ago. Modify actually, wasn't it? I should probably watch the chat. Modify, yeah. Modify, where was the match? Is it just, oh man. The align tool is the fancy one. Really? Snap align. I don't want snap align tool. That's it. Nah, see, that's the line. Oh man. Modify. Oh, thank you. Tells you how much I use this. And in Maya logic, it's gonna be master than target. Let's see if this messes me up. Match transfer. Okay. Not fair enough. Yeah, other way around. See, I wish this was being drawn for me, but anyway. For down, yeah. So, and this is the part where it might not be a bad idea to do this, and I'm middle clicking. If you don't know it, middle clicking a menu, this comes from XSI. We'll repeat the last command that was executed in that menu. It's pretty useful. Yeah. So now that we have these three, and see, this is the thing where in XSI you would have seen them, so we have to move to full X-ray. And these are the joints that we have bound, and these are in word space. We can actually, provided Maya doesn't poop itself, which can happen occasionally. Let me see. And this should be in order actually, but let me make sure of that. Yeah, 1, 2, 3. So yes, they are. Because sometimes, especially if the array gets rearranged, watch the indices. It can trick you. It can be very tricky. So, all right, this is going in, and nothing bad has happened. This I also love, how that text field takes over my mouse input entirely, forever. Number 2. And number 3. I should have prepared scenes, but hey, I'm streaming for free for 2 hours. You guys have to bear with me. Okay, so now, as you can see, our joints are not really responsible for anything anymore. And this stuff is in word space, and there is absolutely no difference, okay? So does this make sense? And I don't know how many people knew this, that skinning works like that. I imagine quite a few must have dug into, you know, into the how it works and how it builds the graph. But that's it. The skin cluster does not care. Okay, sounds like a meme, but that's how it is. It does not care that you have joints. Okay, and even the influence color here is actually an attribute that could come from anywhere, and you can cut it. And you know, this again, this is conflation between tools and the actual graph as an evaluation, as a program. So you don't need joints at all. Now, object color RGB, you know, you can disconnect it and you can build your own script and reconnect these parts so that your joint color for when you paint things is not conflated with your joint, if so you desire. Okay? Yeah, the real tool of the devil. Yeah. And it's kind of silly that this establishes a dependency, but I assume that this massive mega node actually is optimized enough to ignore these things at evaluation time. But Maya skinning, for the record, is very, very slow. You, in a couple of days, you can write something that is 4 or 5 times faster. Is there an advantage in terms of performance to use transform forward joints? No and yes. So we'll get to that next. Now, here's the interesting part. If you ask me, which you haven't, but I'm running the stream. So oftentimes I see people doing insane things like deleting the joints and recreating them and so on, and these all comes from those superstitions. Now it is possible, because of the skinning workflow being somewhat stateful, it is very possible to mess Maya up. The skinning is pretty weak because the graph has been convoluted and complicated to deal with all of these nitty-gritty details. But if you look at the rig from a consumer point of view, the one you give to the animators, right? They don't care about these joints. They care about their effect, okay? So there's no real reason for these joints to exist if literally all they're doing, and we're doing it in Code to Freak, and I'm not going to spend a ton of time on this because these we'll do in the skinning part of Code to Freak, the actual stream with the ball and legs. If this is literally being controlled one-to-one from another object, there is no reason whatsoever for these to exist. Just get the other objects as an optimization stage. Once you're done with the painting, these exist for you to select, have colors, and paint influences. Then it is a very trivial script to write to do something where for each joint, it finds what it's driven by, and it connects the word transform of that thing to here, and then you get rid of joints. You are done. Okay, that's it. You don't need them. You need them for authoring, and that's why I'm saying it's a different rig that you serve for consumption to the rig that you use, for authoring. Now, I'm not saying do it. Absolutely do it. But in regards to the question, like, do they have a performance impact? Not necessarily. But here's the other thing. Very often from my IK solvers, I don't really output from one solver, I don't output a bunch of things that go to another object, again, and so on. Very often I'll output transforms so that anything can use them, right? So if you output free transform from an IK solver so that it can be blended and so on, there's no reason for that node to go out with those transforms straight up to there if you don't have a blend case or whatever. Anyway, let's not confuse these further, and let's do I dare undoing. So the other thing I want to touch on, let me see if I can undo this law and see what happens. I'm also find that skinning in Maya is very finicky with undo. Go slowly when you undo and redo port connections. Now, the other thing I was saying, now we have matched these things to the base joint positions. And very often I was saying, I see people doing crazy things. I'll see you later. Ciao, Matteo. I've seen people doing crazy things in deleting and recreating because, oh, I've lost my bind pose, I've lost my joint orient, I'm screwed, it's like I cannot leave any longer. No, I'm moving a locator, which is silly. Where people go like, oh, if I had rigged this thing, like if the bind pose was just a little bit, maybe they rigged it like this and then they have this pop all the time and we're like, oh, if only I had rigged it like that, And then they go for some insane procedures to restore the bind pose. They use tools here, all over the place, which are very easy to replace, that can't really be trusted, especially if you've messed with the rest of the graph. Then you have to retool all of it. Now, that is not really a scary proposition because it's actually stupid silly to do. Now, the same way that was shown, and ooh, what have I done? Okay, there. The same way that, maybe you want to move, and I've shown guides and stuff like that. That's why I'm saying a lot of these I'm going to touch on more in depth when you come to Code to Freak, but I'm trying to debunk some of the myths. The other thing I've heard is that joints have something to do with the bind post. No, they don't. Now, the command itself, and this is the conflation I was talking about, the command themselves to reset the bind pose, maybe if you select the joint and you want to reset the bind pose, maybe that command wants the bind pose to be on the joint. Because maybe it takes the current transform of that joint and stores it into this bind pose cache that is local, okay? But that is not something that the evaluation cares about one bit, okay? Now, there's a little bit of a funky thing in the bind pose where it's basically a group node that describes several things, right? So it describes the parents as well to the nodes, which is a bit confusing, but it sort of makes sense. So the bind pose goes, there are these many transforms that the skin cluster cares about. That means that I need these many members that have a bind, okay? So that's the 1, 2, and 3. Now, possibly for some optimizations or for some other reason, I don't know exactly why, all of those members also need to have their parent indicated. Remember, these are messages, so all this is doing is indicating something. So the first member goes out and becomes the parent of the second member. So remember your step block, right? 0, 1, 2. So you go, okay, the parent of one, the parent of these is going to be that, which comes from here, right? You don't really need, you could connect the messages straight up from here, okay? Maya probably does it like this again so that the tools can work. If you write your own tooling, you will have to replace these things, but they're all pretty trivial to do. Does this still make sense? Hopefully it does. Let me know if it doesn't. So all of these things really are for the tooling as far as I'm concerned. Because when you look at the mathematical part of it, it is a word transform. Chat, catch me up because I'm going to move on with these unless there are questions and we're almost done. So questions about this part or questions you want to pile up for after this part, put them in. Now, so if I remove those and I don't care about the parents, let's say that they're only used for a tool, some tool, which I don't care about, and I actually connect my silly nose in word space that I've already put in there. No, don't do that. Now that is very dangerous. Lo and behold, if I can actually select stuff, the IK and, and the skinning and everything still works fine. You want to change, you go like, oh, I really wish I had placed these, I had made my default. You will want the length of the bones to be somewhat respected. I just wish I had done this way. You know, that's all it takes to move the bind pose. Now, the problem you have with these, okay, is that this bind pose is just sending a message for the skin cluster to fetch. So as you're altering these things, if they're not joints, if they don't have all those bind poses and all those things changing, you will find that your bind pose doesn't update until you run a digidirty or something else. So I don't want to spend hours explaining how this works, but you can very easily decouple completely your bind pose, which is basically the default transforms, from the actual objects that provide the transform pose. And that can be done there, okay? You can even remove the bind pose entirely, in fact. And I believe that you can mess with quite a few things here. I would have to actually look at a bunch of things. I remember actually hacking these as well to set the base influences. It might be a hidden attribute, but it was a while ago and I haven't used the default skinning since a while. But point remains, there is nothing about joints that begets more precision or stability, okay? Now, the last thing that we want to touch on is why is it a bad idea to work in word space, which is what something is asking. We have the same script, so useful. Yeah. So, let's, man, I've been going for a long while. And so let's get to the last part of it. Why is word space a very bad idea? So let's say that this is being grouped under something, all the bones, which might actually change the way the word space relates and so on. And now, yeah, you can see that this still thinks that the parent is the word space, but anyway, it doesn't matter. This is just for the tooling. I want the IK handle under that as well. So I don't want to spend hours talking about floating point precision, but there is such a thing, right? Everybody's seen meshes. Like some people call it flickering, some people call it frying, whatever. You have Z sorting issues. Now, if I move the IK handle, the joints and everything like that, you know, you expect the skinning to still work, and that's a pretty reasonable assumption. Now, I don't have enough vector. We don't care about that. What we really care about in this case is the precision. Now, you're working on something that is in centimeters, and you have a big set, and you're many meters away from the center. So this thing, your rig, okay, needs to be at, let's say, 100,000 units away from centerward. Let's see if it still happens. Now, what will happen, and it's not happening now, probably because there's not enough elements. Oh, I've also moved the... Yeah, there you go. I've actually practically fixed the issue, haven't I? Anyway, what will happen is that these being all word matrices, and the round number might be helping as well. At some point you will see happening where small transforms, and I don't know if they fix something in Maya 2018, small transform will have a very serious effect and will actually fry, or what is going on here? Is it not taking the 1 million? Have I broken Maya? I have somehow managed to break Maya, or have I hidden it or whatever? All right, there you go. Go on. Anyway. See, what have I done here? What is it? Okay. You will start seeing some serious precision issues. Like now, this is Z fighting, where it's having trouble sorting the triangles. Maybe you can see some flickering around the edges, and this is due to the distance from the center and the magnitude of the numbers involved, right? So where is it now? Is it 100,000? I really wanted my 1 million, and I don't know if I mess with the view. There you go. So at this point, this is a mess. Now, if the mesh itself was 1 million units away, it wouldn't really be an issue. Okay? But the whole chain being that far away, you get all this crap. So somebody's asking, is this due to floating point precision issues? Yes, it is due to floating point precision issues. Because what is happening is that your bind matrix, its center word, and they are word matrices, and they are matrices, so your Euler rotations and all of that, it doesn't matter one bit. Your joint orients don't matter one bit. Is made of very, very small numbers when it comes to the translation, okay? Whereas the transform matrices are actually made now of very large numbers. And to talk about floating precision super briefly, what is happening is that floating precision cares, and I'm simplifying things here, but it's enough to understand. We'll store the number, something like this, and then they will store an integer that will place the decimal point, which is why they're able to describe both very large and very small numbers, okay? So if you get these, and the decimal point part is something like that, what you end up having, well, let's do something a little bit more civilized. What you end up having is all these zeros, and then, your 0 dot and your power minus 10, so your other 8 zeros, and then the number. So this is stored one way, and this is stored in one part of your floating point number, and this is stored as the offset. Now, your very large number might be done the other way, where it's like 300, or actually we had millions or whatever. It might be storing 1, and it might be storing something like 7 as the offset. So what you get is 1, and then you get the 7 zeros. So you get 0, 0, 0, and you get the idea, point, whatever is left for the precision that you have, okay? So in isolation, those two are perfectly fine, and they're going to stay very precise. But when you make very small and very large numbers interact, floating point precision can only store one offset. So at some point, it has to choose what is more important. And normally, it will choose the larger of the two numbers, the one with the higher exponent, because, that's the most significant part of that number. It's the one that represents larger magnitude. So you lose all of these. So whenever you have numbers that are like 1 million or so on, it might seem like the number is round and nice, but your computer doesn't care. How many places away you are from 0 is what matters. The same is in this direction. And when you multiply matrices, it can make a considerable difference, especially if you start having the actual rotation multiplication in the picture. So working purely in word space is super nasty, okay? Now, what can you do about this is, and this is where joints become truly nasty. I don't know if I want to spend the time. This is something that I want to do on the actual regular code streams, but I'm not going to give you the example. You'll have to tune in again, but I will leave you with a thought so that you can play with it. The way to fix it will be that this cylinder, as it is also moved together with the rig, okay? So that it stays at a reasonable enough place, aligned closely enough to the rig, right? Or pivot rotate, yeah, I don't care about that. What happens, however, is that now you get double transforms, okay? So not only it's being moved 1 million units away from this object, it's also being moved 1 million, from these joints being transformed by these, it's also being moved 1 million units away by being parented under these, okay? But if the transforms were in some relative space, so if you could choose what the word space of this is, the more you segregate operations like that, the more precisions you basically keep, you wouldn't have the issue. So actually, I'll show the example because it shouldn't be taking me that long. Now, we don't care about the bind. The bind is being left centerward for now. And that is the other thing where, it's kind of really nasty. But the relative transform should be okay. if you were to take these joint transforms and localize them to that group, right? Then these objects transformed by that group plus the transforms of these relative to that group and not to the word, so they haven't been offset by it, will be considerably more precise. All right, so the way you do it is with a Moute Matrix. And let's see, this might fail horribly. I mean, it's unscripted, unprepared, but the logic is this. You want to take, where is that? Where are you? Oh, there you go. Somewhere useless. The logic is this. If you take the parent inverse of these, it's basically what's required to untransform things, and it goes in the second part of the multiplication. So we can, and you could use the parent inverse matrix from the joint itself if you really wanted to, or from the object. In this case, there's no cycle, so in fact, why don't we do that? Oh, because then we always need the word anyway. So let's not do it. Word inverse. No, sorry, word matrix. You have one attribute. Why do you always ask me where I want to connect? There's only one possible choice. Shift Control D. What have you done? Rearrange my graph and that's it. Rearrange it again. Might as well. So, what we care about is regrouping these. Oh man. See, you build this mental map of where things are, and then Maya decides to rearrange your graph, and you question your life choices. So you see, this is why I was saying I should have prepared the scenes, but we're almost there. Word matrix here. This might fail horribly because I've messed with the bind pose, but you get the logic and you should play at home to understand what is going on. What am I doing here? I'm a silly person. Anyway, doesn't matter. All that changes the order. The numbers are now odd maybe, but... So what I've done is I've just taken 1, 2, and 3 and taken the word transform and multiplied it by the inverse of the group, because the group is the parent of the cylinder. Now I should be able, if the fates bestow good luck upon us, to do 1, 2, and 3 and replace those word matrices with localized matrices. Now you're paying a cost here because you're having all of these piecemeal multiplications. Normally you want some nodes that do it more efficiently, but it's not actually going to cost you all that much. And if you can get rid of a bunch of joints and fish directly from your control rig, chances are this is actually going to compensate and keep you at the same speed, if not going to make you go slightly faster. And there you go. Now your cylinder is not flickering anymore. And that is why word is a terribly bad idea. But the solution isn't local, because local has a lot of costs and has a lot of tricky bits, and it means that all of your stuff that you normally want to be flat and easy to manage for tooling will be pretty messy. So the solution is you want to be able to choose your own word space. Okay, so last myth busted that I wanted to get out of the way. Without joint orients, you lose precision. No, just no. Precision is horrifyingly bad in Maya because it works in word space. If you want it fixed, choose an object space, let's call it that works for you. Write tools to do this job, and always, whenever you work on a rig, if you want to test it, you take it, you flip it at odd angles, upside down and sideways, you move it 1,000,000 units away from the center. That's where you see the issues. If you wiggle things in place, you will never see issues. You will especially never see precision issues. Turn it around, move it 1,000,000 units away, you will start seeing some real precision issues, and whether you have fixed them or not. Now, the last thing to add to this is this has just broken all of the way painting tools and everything. So you have to write yourself a script or something that swaps between these two states of object space and word space. there's a bunch of other things that were in that thread that I wanted to meet bust, as in, you know, things like exporting and so on, but we don't have time, and I will need to like kind of build a ghost rig like it's used for games to demonstrate those. But I reckon this was a solid go at the problem. Write a new paint tool. Talk to there is a good paint tool. There's NG Skin Tools there, and from what I know, I don't know if Victor is online right now. It's super late for him at this time, but he might be. I think he usually watches Cult of Rig, at least on YouTube. The guy that writes NG Skin Tools is like, he's a really solid guy. He's switched on, and I know he is doing a lot of work. Talk to him, and you know, and buy his stuff. I mean, I don't use it, to be honest, but that's because, well, I haven't been doing, you know, like menial kind of like asset. Well, not menial is absolutely unfair, but asset centric rigging in a while. I've been on the technology end of things for many years, but I don't even know how anybody can use Maya without some replacement for the painting. Now, the reason, sorry, I went off this other tangent of mentioning that and mentioning Victor, because if you find that you often need these, and maybe NG Skin Tools already has it, maybe talk to Victor and ask him if he's willing to give you a couple of tools and support a couple of modes where you can choose an object space. Because this is how you deal with the problem. That's the end of the story. There's other things that come into play with shapes and other deformers and so on, but that is the only source of precision issues in Maya, and no amount of joint orients or joints or anything will fix it. And at this point, you know, you could very well delete all of these joints and connect the transform straight up. Do we have any more questions? I'll give it a couple minutes, then I am gonna close this. I've been at it, what, a couple hours now? Yeah, just short of a couple hours once I'll have spliced the things together. Alright, thanks everybody for watching. It has been a pleasure, and we only got moving cylinders. I know it's not super visually engaging, but I really wanted to get this off my chest, because there's no magic to IK. Joints are complicated the way they are only because they need to support the toolkit. You only need a very small subsection of that toolkit. Please learn what these things do. Don't treat any of these as black magic. Don't buy into buzzwords like buffer joints and double joints and auto-orienting joints and all this stuff I've heard about. It is nonsense. Joints are just transforms with added baggage that you do not want to lug around. Use them at their absolute minimum set of parameters that you absolutely must deal with it because of circumstances or because of the parts of the Maya toolkit that you use, and, you know, learn the basics behind the rest because they're not that complicated. Cool. Have a good day, everybody. Thank you for watching again.